When you're given x squared plus bx plus c, completing the square is not that hard. But if you have something in front of x squared, then completing the square becomes quite a task. So there are many different approaches to this, so I can't say that my method I'm presenting here is the best, but it's one of those methods. So the way I would do it would be first factor the a out, and see, I had to replace b by b over a because if these two are to be equal, then when you multiply a, b over a times a will cancel and you will get bx again, right? So you take the a out from the first two terms, and then what you do is you take the half of b over a, like, dividing by 2, you take the half. That's same as multiplying 2 in the denominator, so you have this thing here. You take that number and you replace this thing by b over 2a squared, and then you have to subtract a times this thing squared. So you can think of this as the formula for completing the square. Now, to understand how the left side and the right side is equal, you should actually do a computation to show that it's actually indeed the same. So let's try this. You want to first apply this formula. A plus b squared is a squared plus 2ab plus b squared. Hopefully you know that there is this 2ab if you expand this. Okay, using this and applying it to this squared, x plus b over 2a, then it will be the first thing squared plus twice of first and the second thing multiplied, and then the third thing squared, which is b squared over 4a squared, and then 2 and 2 cancels, and then you have x squared b over ax plus b squared over 4a squared. Okay, so having done this much, let's try to see what this will become. It's a times x squared plus b over ax plus b squared over 4a squared minus a times, this is, if you apply the square top and bottom, it's b squared over 4a squared as well, plus c, and then if you multiply the a's, you get ax squared plus a times b over ax plus a times b squared over 4a squared minus a times b squared over 4a squared plus c, and you can see that these two things are same, and a also cancels, and you get ax squared plus bx plus c. So you can verify that this formula is indeed algebraically equivalent to this, because we went from here and simplified to this side. So in math, if you can show that b is equal to a, that means a is equal to b also. So that's why we have verified that indeed these two are the same. Okay, so given that this is the formula, let me write the formula again just so that you remember. So the way you do it is take the a out, and then whatever you get for here, you take the half of it, which is b over 2a, and then you take a times this squared and you subtract it, because that's like the unwanted term that will be produced. So that's what you get. Now let's do some examples. Say you have 2x squared plus 3x plus 5. Then according to this formula, you factor the 2 out, you get x squared plus 3 over 2, x and then plus 5 at the end. And this formula says, well, you take the half of 3 over 2, you put that inside the square, so it's 3 over 4 squared, then minus twice of 3 over 4 squared. Twice of 3 over 4 squared. And then you still have the 5. And then you have to simplify this much. 4 squared is 16. 3 squared is 9. Times 2 plus 5. And 2 and 16 will make this as 8 if you reduce. And then 5, you have to make it into 5 over 1 and multiply 8 top and bottom, so you get the common denominator. And what do you get then? You get 9 over 8 minus 9 over 8 plus 5 times 8 is 40. 40 over 8. 40 minus 9 is 31, so you end up with 31 over 8. Okay. Let's just do one more so that you remember how this thing works. Say this time let's use some negative values, so something more complicated. 5x squared plus 4x minus 3. Okay, so we have some negative value here. Okay, first factor the 5 out from the two terms. So the second one will have 5 in the denominator. Then you take the half of 4 over 5. Well, half of 4 over 5 will be 2 over 5, right? So you take that, x plus 2 over 5 squared, then subtract 5 times this squared. So 5 times 2 over 5 squared. You still need this minus 3. And then you have to simplify this part. So let's just simplify that. Negative 5 times 4 over 25, because 2 squared is 4, 5 squared is 25, minus, well, since this 25 and 5 cancels and you end up with 5, that means you need to make common denominators by multiplying by 5 top and bottom. So you have negative 4 over 5 minus 15 over 5, which is negative 19 over 5. Okay, so you end up with 5 times x plus 2 over 5 squared minus 19 over 5.